Welcome to the Crazy Hat Chemist. So here we go, another video on periodicity. So let's get moving. Bam! So today we're going to be talking about chemical properties within a group. Okay, an associated chemical property occurs with an increase in radii as one moves down a group. Excuse me. That is, the valence electron or electrons are held less tightly as one moves down a group, causing the electron to be more readily removed and therefore more reactive as one moves down a group of metals. Okay. Furthermore, within the same group, note the same number of valence electrons, of course, there are similar types of chemical reactivities with either the metals or the nonmetals. So here are some examples of some chemical reactions. Lithium plus water gives me lithium hydroxide and hydrogen gas. Sodium and water gives me sodium hydroxide and hydrogen gas. Potassium and water gives me potassium hydroxide and hydrogen gas. So those are all group 1s. Here are two group 2s, and that is magnesium and water gives me magnesium hydroxide and hydrogen gas. Calcium and water gives me calcium hydroxide and hydrogen gas. Notice that all these are metals, plus a water yields me a metal hydroxide and hydrogen gas. Okay? As you move down a group, this reaction becomes more and more violent. So as you go down group 1, for example, lithium and water, kind of sparkly, fizzy. Sodium and water, even more. And potassium and water, even more violent. And rubidium, even more violent. And cesium, the most violent of all. Francium, there isn't enough of that around to make that reaction occur in reality. But with cesium, it's very violent. And the reason is because cesium's outermost electron is very far away from the nucleus. And being such, it's very readily removed. Okay, so here are some other examples of some non-metals and their chemical reactivity. That is sodium and a halogen, that's bromine. And you get sodium bromide. Sodium and chlorine, and you get sodium chloride. Okay, so those two are those combination reactions. So chemical properties within a group are relative to their valence electrons. Valence electrons are the electrons that interact chemically. Therefore, the valence electrons are associated with the group and are predictors of chemical reactivity. Remember, the valence electrons are the outermost electrons, s and p type orbitals of the largest principal quantum number. So here are the valence electrons associated with the groups 1, 2, 3, 4, 5, 6, and well, we'll forget about the noble gases since we really don't deal with them a whole lot. But the rest of it are 2 because those are in the boot. Okay? All right, so here's some atomic and political humor combined together. All right, what is a politician's favorite subatomic particle? The electron. Thank you very much, Jacob Block, for that one. Okay, what is the element PO? No, it's not polonium like you might have thought. Okay, it's politicum. Politicum. Okay, this element contains a great deal of gas. It is similar to radon in that it can reach lethal concentrations in the house. Okay, what element is Cg? Can't find it on the periodic table, can ya? Well, it's just been discovered. It's congressium. Okay, this element is atomic number 535. This element can never be found in the solution. So, if you like that political humor, atomic humor, if you will, or you just learned something cool, that is fantastic. Hopefully that's even more. This is one of my favorite hats. It's a cork hat from Australia. Give me a thumbs up if you like that video. Subscribe to my YouTube channel, especially if you want to learn some more cool chemistry. And keep on learning your chemistry. I will see you next time for another video. Bye now.